question, we're given a curve C with the parametric equations x equals 3 plus 2 sine t and y equals 4 plus 2 cos 2t. And there's a restriction on the domain of t as it is between 0 and 2 pi, where it can equal 0. Part A asks us to show that all points on C satisfy y equals 6 minus x minus 3 all squared. Okay, so notice that this equation here does not feature t at all. So essentially, we need to find a way of eliminating t from these two equations. So the first one to deal with is this one, because we can easily rearrange this one to find out what sine t is. So if we start off with x equals 3 plus 2 sine t, that simply switches round to sine t equals x minus 3 over 2. Okay? Now, this equation here, we're going to try and rewrite in terms of sine t, because at the moment it's cos 2t. And we can do that. If we rewrite cos 2t using one of the identities that we know, that's 1 minus 2 sine squared t, or as I've written it, I've actually written it as 2 sine t all squared, because that just makes it obvious where my substitution is going to be. Okay, so now we're going to use the equation for y, and we've got y equals 4, and instead of plus 2 cos 2t, we're going to put plus 2, and then replace it with what we've got for cos 2t there. So 1 minus 2 sine t all squared. Okay? Well, fortunately, we know what sine t is. In terms of x, it's x minus 3 over 2. So we can substitute that in there, and then we'll have an equation in terms of both y and x. So let's replace that one in there. And expand the bracket at the same time. Okay. A little bit of tidying up on the outside. And then your final step is to expand that last bracket. What we've done there is we've squared that denominator, which is 4, and of course 4 times anything with denominator of 4 will just cancel those out. And we're left with the equation y equals 6 minus x minus 3 all squared.